All right, if you watched our last video, you'll see that I'm not going to do anything different this time. I'm asked to multiply two radical binomials together, so I like to use the box method for this one. So let's go ahead and start. I'm going to multiply rows and columns together, and keep in mind numbers outside the square roots will multiply and numbers inside the square roots will multiply. So for this first box, 7 square root of 2 times 7 square root of 2 becomes 49. Times the square root of 4. Well, of course, square root of 4 is just a regular 2, so this is really 49 times 2, or just 98 once this box is simplified. All right, next box will become negative 21 when I multiply the numbers outside, square root of 6. Square root of 6 can't be simplified, so that box stays as is. When I move to the bottom row, 7 times 3 is a 21, and then a square root of 6. And you may notice something right away about those two boxes. We'll talk about that in a second. And then finally, this last box, 3 times negative 3 is a negative 9, square root of 9. And of course, once again, hopefully you're recognizing that square root of 9 is just a 3. So negative 9 times regular 3 becomes negative 27. So to finish this problem, if you remember the last example, we're going to go ahead and add up any like terms that we have in the box. And in the last example, we saw that we didn't have any like terms, and we had a horribly long, awful, nasty answer. Well, this time you're probably noticing that you do have like terms. You have the same number inside the radical, so those are like terms. But when you add up 21 square root of 6 to negative 21 square root of 6, those boxes just cancel out, so those are gone, which means all that's left is just a regular 98 minus a regular 27, better known as just 71. And so you may be wondering why this example worked out to be such a nice, neat, perfect integer, and our last example was so nasty. Well, if you look back at the original problem, there's one thing that makes all the difference, and that's the fact that you have identical parentheses, except for one is a plus sign, one is a minus sign. If you remember, these were things called conjugates, and we have used conjugates in the past for just this purpose. Because when you multiply something by its conjugate, you get rid of all the weird stuff, all the square roots. We've done this with I problems. In our next couple of videos after this, we're going to be dividing, and once again, we'll be using conjugates to get rid of square roots. So that's what made all the difference. That's why this time we got a nice, neat integer, and last time we had such a nasty, awful, irrational answer.